All right, I think we are live now. Hello, everyone. So, very good evening to all, firstly, and thank you so much for joining in. I guess like my internet is not working right now here. Just give me a sec, like so I can actually read the chat. Meanwhile, I'll be sharing my screen here. Let me just start this. Okay, I hope now this is visible. All right, yeah, this is. So, yeah, so how are you guys? Tell me. Good evening, Shiva. Good evening, Just Insane. Hey, Insane. Hey, Kuldeep. Hey, Aziza. Hey, Umesh. Hey, Bhavya. Hey, Vidya. Vidya Lakshmi. I think I have read this name before, if I'm not wrong. Like, hey, Vidya, like, have you taken my sessions before? Because I do recall your name. Umesh. Hey, Bhavya. Hey, Vidya. Okay. Good evening. Can I get my certification? Hey, Abhinav. Good evening. Colorado. Hello, Jatan. Mega R. Saurabh. Hello, Saurabh. Hi. Hello, everyone. So I hope you people are doing fine, right? And yeah, I do recall your name. Okay. Okay. And thank you, bro. Let's start. Okay, like without wasting a single second, let's literally dive into the concept of machine learning, like what exactly this will be all about. So I'm not, I will not gonna get into the, like the details of the machine learning. I will just gonna give you the overview how exactly it works on a superficial level. That will gonna give you a basic understanding about like how you can interpret this entire machine learning thing in your own, like in your own language. So आपने नाम के लिए attendance completed. Hi Gopal ji. Thank you Naveen ji. Thank you so much. And hello Srilata. Hello Insaf. All right. Okay, so let's get started, shall we? Okay. So what exactly this will be all about? So machine learning. What exactly this is? Right. Machine learning. So I will not gonna get into the like the super detail of how exactly the literature of the machine learning actually works. Rather, I will gonna give you the overview of each machine learning system in this session. So let's get started. So first thing you need to understand what exactly the machine learning is. Okay. So let us say how exactly it differs from your traditional programming approaches and how you can make the most out of it in the first place. Okay. So let us say in traditional programming approaches, like let us say I will just gonna get into the task or the or the project, or you can also consider this as a project or a scenario. Just consider this scenario where you have been given a task of determine determine if an email is spam or not a spam, right? Okay. Well, in this case, how exactly you will gonna go with this approach? Okay. So let us say we've got two ways. The first way, like here, can be if I just make us like that. Let us select this is your email here, right? And in this email, you will be having the subject written here, right? And with along with the subject, you will gonna have a text or body. You can even name this as the body of the email, right? And for the subject, whatever it will be, like like, and the text can be anything as well here in this case. So now what exactly we need to determine? Based on this, if I pass this email to a filter, my filter should be able to decide like if it's spam or not a spam. These are the two ways I need to like get done. Like, right? Like this is what I want as a result. I hope the scenario is clear in your mind. Okay. So let us see the very first approach, what exactly the traditional programming you will just gonna look like. So let us say for the traditional programming approach, we will just gonna go with the body. Body of the text could be anything like the main message of the email. So in this case, let us say the email actually reads as follows. So let us say I am the Prince of Nigeria, Prince of Nigeria, right? Offering $1 million. Enter your enter your details, bank details to be specific. This is something about like we're just gonna look like a spammy email, right? And let us say we've got like this is only one email, and let us say we've got 40 of those here. Okay, so let us only focus upon this one, like how exactly this number will just gonna help us as well. But let us say we've got 40 emails as such, and only focus upon the very first one, which I just described here. So with your traditional programming approach, how would you solve this problem? Well, let's see. So for the body here, I can just look for some words which actually usually like comes along with the spam email. So for this one, let us say the words or the spam words are, let us say, dollar, million, free, prince, right? Lottery. These are the words which are spammy. Okay. And now, what exactly my the programming approach will just gonna look like? So for this one, I can just go with this one. If I write a pseudocode for filter or the for the machine algorithm or machine learning algorithm, how exact not the machine learning algorithm, but to for the machine to determine like if it is spam or not is spam. How exactly we're gonna like this gonna approach will just gonna fall into that into that scenario. So what I can do here, let us say if any word in spam words, right, declare spam email, right, else not a spam email. This is something we need to like we can actually go with that, right? Like this is how I would approach if I only knew traditional programming, right? If I had no clue what exactly machine learning could be. Right. Well, okay, maybe for once it may work, right? But when it comes to like, let's say, like the fraudster actually got to know, like, okay, you may have flagged these words. He would be obviously super smart about it and can literally change those words. But the problem here arises when these words actually starts to change innumerably, like there is no number, like literally I can make more and more changes in this text here, right? There is no limit to that. Okay, so how long you will gonna keep make those changes in your code, right? You don't really know. Okay, right? Now let's actually try to project this problem with the help of linear algebra. I know machine learning literally for machine learning literature, the language of machine learning actually is linear algebra. Just remember this. And if you are not aware of linear algebra, let me actually teach you what exactly this is. Like it's quite easy. We will be just dealing with this y is equals to mx plus c. This is it. Like, okay, here m is the slope of the line, x is again a variable and C is the intercept. All right. Okay. So if I remove this, okay. So let us say if I write this here like this, we've got these lines here. So let us say if I plot out this, okay. And out of like we've got how many? If you recall, like how many emails did we have? 40. So let us say I just took out a sample out of those 40, and I'm taking only 10 emails. And out of those 10 emails, five are, let us say, if I represent one as not spam, or like let's actually make it as a spam, and zero as not spam. All right. So now in this case, let us say, okay, and also like on this x-axis, we've got emails, or on this y-axis, we have got the, I would say, class. The class here could be your 0 or 1, spam or not a spam. That's it. Okay, so your x value here is emails, and your y value here is class. Simple linear algebra so far, like not even linear algebra, we are just literally plotting out two axes, x and y here. And this is your x-axis here, and this is your y-axis here. Right? Fair enough? That's great. And now let us say, like, out of those 10 emails, we've got 6 emails as spam and 4 emails as not as spam. So how exactly I can draw these values here? So for each y value for x-axis, what exactly the value for the y? Like, what is the y value for x-axis? Come on, guys. It's 0, right? Okay. Like let's say like this is x1, this is x2, this is x3, this is x4, and each coordinate of each of these points will be, y coordinate will be 0, right? 0, 0, 0, and 0, right? So what I can do here, so this x-axis can represent my not a spam, right? So I've got 4 points here which represent not a spam, because here in this case, this is representing my y. This is representing my y. Okay, right. So I can also write it here: x1 comma 0, x2 comma 0, x3 comma 0, and x4 comma 0. Focus, guys, just focus here. I'm literally taking the very basic concept of linear algebra, which in this case is nothing but a linear line, a straight line. That's it. That's all I'm doing here. Okay, and now let's focus upon these 6. Like we've got 6 spam emails as well, right? Okay, so for that one, let us say, like let's say we've got here. I can actually extend this. I can literally extend this line here. Let me actually extend this line. Okay, I can extend this. And now in this case, let us say we've got here x5 comma 1. Like let us say like this, this entire distance is 0 to 1. Like, this is your 1. x5 comma 1, x6 comma 1, right? x7 comma 1, and x8 comma 1. And assume it like, x9 and x everything, x10. So we've got 6 values there. Okay, so we've got here values here 1, 2, 3, 4, and 5 and 6. Okay, so I can just draw here. Like 1, 2, 3, 4, 5, and 6. It's much easier. And just remember, each of these, each of the y coordinate of these points is 1. Y coordinate is 1. So basically, it represents these emails are spammy emails. And now let's see. So since we have got few points here, why don't we actually join these points here? Let me actually join these points here. And I can also join these points as well. Okay, like not with that color, because this might actually like give you some different intuition. I can actually join these values like this. Assume like, okay, like this. Assume it like this. And I can also join these values like this. Okay, and now in this case, what if, now I've got 2 options here, like, okay, but let us say I actually make this graph like this, continuous graph. Like those values are continuous here. Focus here, guys. Okay, focus. All right. So now Now let us see. Now let's actually focus. So what exactly is happening in this entire graph here? So on the left hand side, what do we have? Or on the right hand side, what do we have? So on left hand side, if you notice, all values are what? Not span, right? And on the right hand side is span. I hope you are getting this. Yes or no? Please let me know in the chat. Like, are you getting this point or not? Like, let me know. Yes or no? Meanwhile, I'll be having some water. What is the problem you are having? Please let me know as well. Thoda thoda. Yes. Okay. I would like to know where exactly you are feeling tripped over. Like where exactly कहाँ पे issue आ रहा है guys? मुझे आप वो बता दो कौन से पार्ट में इशू आ रहा है मैं वहां पर रिजॉल्व करने की कोशिश करूंगा ओके x axis is number of emails does not correspond to span. Okay, x axis is for emails, not number of emails. Any x1 value, like this could be your email number one, this could be your email number two, this could be your email number three, this could be your email number four. So these values are emails. Okay, let me actually cover this up again one more time. Okay, let's actually do this one more time. So what exactly the task we have in our hands? Okay, so we need to determine based on a text. We need to determine this is not even coding. Like I'm trying to make some connection here between the data we have. In this case, is these emails, right? And the linear algebra, like the math behind it, like the power of the math. I'm just connecting these two concepts here. Right. Okay. So what exactly I'm trying to do here? Let us say like I project, like I'm taking all emails on the x-axis. This is your x-axis, and all the classes related to the associated with those emails on y-axis. What do I mean by that? Let us say if I say email number one, I am saying here it has a zero unique label. If I say email or class two, it has a one class. So when I say email zero, email two, so it basically means it is a spam, and it means it's not a spam. That's it. All right. And now each coordinate on x-axis, right? Each y coordinate on x-axis is always zero. Just remember this. Okay, so therefore I'm having like for email number one we are having as zero, email number two we are having as zero, email number three, email number four. So x1, x2, x3, and x4 are what your not spam. All right, and similarly we've got here like let's say we have here x5, we've got here x6, x7, x8, x9, and x10, and these are spans. Okay. All right. So now let's again focus here. So if I go left on this, like let's say if I make a perpendicular line, let us say if I draw a perpendicular line from here to here, like let's say from here to here, like let's say like this. Okay. And now if I notice or observe on the left hand side, like on the left hand side, all my data points here, what exactly those are? Those are nothing but not a spam. Okay. And now in this case, these are your spans. ठीक है? Clear है? कोई issue? Please let me know if that is the case right now. Okay. If not, just let me know. Okay. Okay. Mega is saying yes. Mansi is saying okay. That is great. Got it. Yes, sir. Okay. All right. That is great. Okay. So let's move forward. Okay. So this like although we have not covered anything about logistic regression, but what you just saw right now, even without knowing anything about machine learning, we literally created a classifier. This is a binary classifier. What we just saw is a binary classifier. Binary basically means like no value being 0 or 1. That's it. That just means binary. And classifier, which classifies between 0 or 1, hence the name binary classifier. Okay, and this is actually the power of machine learning. So now what we can do, let us say like now literally we can like that is the task to basically determine the shift of this horizontal like sorry vertical line. That is another thing to discuss. But in this case, just imagine like let us say we've got 10 of these data points. And now all we need to determine rest of those 30 data points which we had earlier, right? 30 emails, I would say, which we had earlier. We just need to project that data onto this XY plane, and like those data points will be somewhere around here, right? We can literally project those data points, and those data points will be segregated by this vertical line for being spam or not a spam. Okay, so that is the power of machine learning. So you try to estimate. So what exactly you are trying to estimate here? So with the traditional programming, if you notice, with your traditional programming, what exactly you had? So with the traditional programming, you had, let's say, emails, right? And we also had what? Uh, labels or class, I would say, right? And we need and we had rules. Like we have these three parameters. And in traditional programming, what exactly happens? Like let's say, like in traditional programming, I'm just naming it as TP. What we pass here, we pass emails, okay, and we pass here, let's say rules, and we predict a class. Emails rules are class. What exactly your rules were like? You saw those like when we were flagging those words, right? That was your rule. So what if now this is actually problematic because this rule which we are like passing in this traditional programming approach is a manual approach, and based on this manual approach we are determining a class, and this is extremely limited when the data literally like explodes in billions or maybe like trillions. You cannot manage that scale of data. How long you will just gonna write rules for each set of change or like whatever the minor tweak someone actually makes? Well, in that case, this traditional programming approach will just gonna fail. Now comes the part where data actually like explodes, but we need what if we actually determine rule? Okay, so what your machine learning actually is all about? What if the core idea here about the machine learning, core idea for ML? What if we determine rules based on emails and class, right? Okay, and those rules and these rules will be further, these rules will be further, like helping in, these rules will be further helping in us what? Estimating new spam or not a spam filters or like emails. So for a traditional, for a machine learning approach, how exactly it will gonna look like? So no, not like this. So for the machine learning, let's say this is your ML approach. So you pass your emails, you pass your classes, and you basically determine rules. Okay, and those rules takes unseen data. Unseen data basically means like whenever a new email pops in your inbox, and those rules will gonna determine like what will be your estimated class? Okay, so you have got your original class here, right? This is your original class, and this is your estimated class based on the rules which you basically came up with your machine learning approach, which we just saw here, like here. Hmm. So now, is this clear to everyone? Why exactly do we need? Why? What is the reason there? We actually need machine learning, and why? Like, is why clear or not to everyone here? Is this clear to everyone? Everyone, like literally everyone. Just let me know if not. Okay, that is great. All right. So now understood. Traditional prog can work for new data process. Yes. Please, if someone is saying not clear, please mention what is not clear. It's quite vague to give a statement like not clear. What exactly not clear? Please also mention that. Mm, okay. All right. Okay. So let's actually further this entire session. Will you repeat? Yes, sure, I can repeat. So what we do in traditional programming, we basically take emails and we take rules. Like if you see here, right, like for this one, like this is your traditional programming. So we are taking emails and we are taking rules. This is your rule. Like this is basically your rule. If any word in spam, like if any word, like if any word from body, if any word from body does exist in does exist in these words, I'm just gonna declare this as spam. Otherwise, not as spam. So this is a rule, and we are hard coding this rule. It is not at all like this rule does not have its own intelligence. And we want to actually automate this entire rule mechanism or rule schematics. Okay, all right. So now, and what if like this is, or and we were basically determining based on these rules, we were determining a class. Like if a class, what exactly is the class is here? It is 0 or 1. Like if it is a spam or not a spam. Right. So what exactly is your task here? Determine if an email is a spam or not a spam. So here, not a spam is referred as, 0, and spam is referred as 1. Right. Let's say we've got two students in the classroom, Girdhar and Gopal. Right. So I can name myself as 0. I can refer myself as 0, and I can refer Girdhar as 1. So I binarized two people here based on some values. Okay. So that is how you can actually see it. So how many emails move to class like spam or not email? 40 emails. If you paid attention here, I took 40 emails here. 40, right? Okay, I hope this is clear. So I'm moving forward. So that is the main reason why we need to understand machine learning. Okay, and honestly speaking, I cannot go dive deeper into how exactly a machine learning algorithm actually learns, but I have taught that earlier and on the very Let's Upgrade channel here. So please go to that machine learning playlist and you should be able to find that video. I literally have covered from you like head to toe of how exactly an optimizer actually works. But now let's actually talk about machine learning systems here. So now we know what exactly the machine learning is and what kind of problem does it solve, right? So also let's talk about, are there any different kind of machine learning systems which we are not aware of? Okay, so let's actually talk about those as well. So machine learning systems. So the very first one we have here is supervised ML system. Second is your unsupervised ML system. Third is your reinforcement learning. Okay. Okay, so let's actually try to understand each one of those. So for supervised machine learning system, what is this? So for supervised machine learning system, okay, so we've got a pair of feature and label. What do I mean by that? Okay, so let's see. And we basically predict the label, and based on the pair of feature and label, we estimate a label or rule basically. We basically, like we try to come up with a rule which estimates the label. Okay, so if I give you an example here, let us say uh, cat versus dog, and if I go here, so let us say these, like you got here the image of cat and dog, and open image in new tab. All right. So for this one, this is obviously a dog, if you notice, and this is a cat, and this is actually an adult cat, if you notice. I guess like this will be not a good example because I need a bigger one, a bigger or more matured like dog and cat. So I can just go with this one. I guess like this is much better. Do I have better pictures of cats and dogs? Yeah, this is much better actually. Okay, so open image in new tab, and there you go. Like this sucks. Sorry, I can actually zoom in, I guess. Yeah. Okay. So now let's see. So if I now, so for the dog, okay, let's actually, I'm just gonna segregate this entire page across two sections. I'm just gonna name this as a dog features. Okay, and I can just based on like let's say you've got two tables, features and labels, features and labels, or class. Sometimes even referred as class. So features. So what kind of dog does have a ear? Like what kind of ear those are? Like saggy ears, I guess. Right. Bigger nose, bigger nose. Right. And maybe like bigger mouth. Okay. Big paws. So let's actually go with only these features here. These are your features and labels. Uh, based on this, uh, based on this, uh, I can actually have better, I guess, table system here. Okay, so label what exactly this will be. Okay, the label will be what? Like dog, right? Because it has, if I talk about a dog, okay, so this is not working here. Okay, now it is. So this is the set of feature and pairs. Like whenever I see these features, I'm gonna associate those features to a dog. Right. Similarly, instead of being saggy, those ears are pointy this time. Ears, right? These ears are pointy. Okay. Like smaller nose, right? Maybe like smaller mouth too, and smaller, maybe like paw as well. So these are my features for what? For label being cat, and this is for dog. Now let's see how exactly we can actually turn this entire problem into a data set or something. So let's say we have got here feature, and we have got here the label here. So when I say bigger nose, I can say like it's a dog. When I say bigger nose, okay, let's actually these features can be decomposed across single individual features. So I can say here nose, ear, or paw, and also exactly this was or mouth. So these are your features, and I need to determine based on that like what exactly my class will be. So what exactly my features are here? These are my features which are common across these two entities or these two like dogs and cats here. So features are like these, nose, ear, paw, and mouth. Okay. So if I say bigger nose, if I say bigger or saggy ear, bigger paw, and bigger mouth, so class will be what? Dog. And if I say smaller nose, so pointy ears, Smaller, like paw and smaller mouth, it will be a cat, and so on and so forth, right? This will just gonna happen. Okay, so now if you notice here, like in supervised machine learning system, what exactly we're gonna have, like you can literally take a matrix. Yes, I will gonna come back to it, but what you can do here, you can have n features. So I'm just referring them as f1, f2, f3, and fn. Okay, let me actually determine, or let me actually like represent these values in a matrix. And each feature further can be like each set of feature can be further or like referred as a sample. So I can say here x1, x2, and xm. What do I mean by this? Let's see. So when I say x1, like it means basically this row. Okay, and this row can have any feature value, like the way we actually saw paws, noses, ear, like such. Okay, and each value will gonna map to a y or a class in this case, slash class, or sometimes even referred as label, like 0101 or something like that. And this the order of this matrix will be what? M cross n. M rows and n columns. An order of this matrix, this is again a matrix, but a singular matrix, right? Like it has only one column here, but m rows. So order for this matrix will be m cross 1. And this is actually the sorry, this is actually the data representation of your like machine learning systems or even in literature. Okay, so this is for supervised machine learning systems. So is this clear to you or not? Just let me know. To every one of you. Any questions, guys? Just let me know. Is this clear to you or not? Okay, I can take like 30 seconds of a window cap. Okay, that is great. Okay, ठीक है. So let's actually go for the unsupervised one. So supervised machine learning system is clear to everyone. Okay, now let's actually talk about unsupervised one. So second will be your what? Unsupervised ML system. So भाई क्या है ये भी देख लेते हैं. What exactly this is? So in unsupervised machine learning system, you only have features. We only have features and no labels associated with them. With them. Okay. So when I talk about the like no the data set, if I represent this value, this matrix as D, okay. So in this case, D is a pair of F n comma like no, I can just say pair of X I comma Y I. This is it, right? This is basically how you can actually represent xi comma yi. For each xi, for each xi row, you're gonna have an associated value to yi. But for unsupervised learning, you can only have only xi's here. Maybe like you will just gonna have features value here, like feature values on. Okay, so the matrix will just gonna look like what? It will be like what? Like this f1, f2 till fn, and it will be x1, x2 till xn. Sorry, m, and this is how it will gonna look like m cross n. Okay, and what if like, and also like I know, but this is called like a column vector. Sorry, a column vector, and this is your row vector. Just remember this, right? And we basically feed row vectors into our machine learning system, or like for to train a machine learning model. Okay, clear है? ठीक है? Okay, so like this is your unsupervised machine learning system. And to give you an example of ML systems, okay, you can actually consider this as recommendation system of Amazon.com. Okay, so if I go here, let us say if I go with the Amazon.in, and like you can see here, like I have seen, like I'm like this is my account, and for me, like let us say what exactly we can actually have. Okay, so I actually was looking at these beautiful telescopes earlier. Okay, so when I actually go with these telescopes, so you can see like all I have right now, let us say all I have right now, this image. I know like you might be thinking right now, you may be thinking right now, like what exactly the deal with the images right now. But let us say you only have these images or your XI values of these images. All you can do right now to look for these similar images. You don't know how exactly they look like. Like, sorry. You know how exactly they look like, but you don't really know their names. Let us say, like, let us consider that scenario. And all you can do, you can just look for similar objects, right? So similarly, if you never knew this object name, like in this case, this is a telescope for sure. So what you can see here, like just below this here, you can see the similar telescopes are just popping up. Like this is your recommendation system. So based on a single like single feature, not a single feature, not necessarily, or a bunch of features, we can recommend similar set of features, sorry, similar set of row values, right, or sample values, or elements, or anything like your objects, right? In this case, like this is your objects, like telescope. And not only this, your even your Netflix, basically works on recommendation system. The more you see kind of a any kind of genre, it will just gonna more recommend you more and more. Like let's say you watch anime, it will just gonna recommend you. Netflix will just gonna recommend you more and more anime to watch. So that is how your unsupervised machine learning system works. Okay, you do not have any label associated with any of your sample rows, okay, at all you have sample rows, and based on that you have to find some sort of similarity, okay, based on like some matrices, like there's a method called matrix factorization. That is how we determine recommendation system. That is how we basically develop a recommendation system. Third but not not the least, or last but not the least, so it is your third is reinforcement learning. So what exactly this is? So I believe you may have actually played with maybe like an animal, like not in a way like pet animal. Okay, a pet. So let us say we've got here a dog. Assume this is a dog. And dog, like basically what you do, let us say you want to perform, you want to get performed three actions from your dog. Actions are what? Let's say play dead. Like only one action. Let's actually not make this complex. Only one action, play dead. So whenever you trigger something, trigger like let's say an event, the dog should be able to play dead. Okay, so now let's see. And now if dog, now let's say if dog play plays dead, you will gonna reward the dog, else you punish the dog. Okay, so now let's see like how exactly it will gonna happen. So what is your what exactly is your basically goal is here? So you need to maximize this reward here. Okay, so what we do in reinforcement learning, you usually have, like, you always have an agent. In this case, this is a dog, right? This is the dog, and you reinforce a behavior on your agent based upon some like policies, which carries out an action based upon an event, like based upon a trigger or an event. Okay, like in this case, this one. Okay, so reinforcement learning is like no, you can actually consider a reinforcement learning agent as a dog. Like you basically train your dog to carry out your desired behavior. Like if you want your dog to play dead, he or she should play dead. Like if you were just gonna teach your dog over and over, right? When I say he or she, like it should be he, because for the dog the feminine is bitch. Okay, and yeah, okay. Okay. All right. So this is your like the general overview of your machine learning systems. That's it. Now let's see the code as well. The very basic code. Okay. So let's see. So if I go with the binary, no, like we can actually go with the sklearn, uh, like and logistic regression. I will gonna come back to it like maybe tomorrow. But let us say like how exactly the code works here. This is something important. Something important. So if I show you here, okay, they haven't actually. Was looking for more. Okay. Yeah, there you go. All right. So like basically they do have actually here three classes instead of two. Okay. And it is for load iris. Like iris dataset, like they have three classes here. Satosa, versicolor, and virginica. So based on some set of features. So the features which we will gonna have for these classes, like let me actually show you. Iris dataset. And if I go with the images, this is the dataset here. Open image in new tab. All right. And if I zoom in, this is the data set, right? And what we need to determine here, the task is here. Task is here to determine the species based on based on sepal length. I will just gonna name it as SL, sepal width, petal length, and petal width. These are four features. And your classes are versicolor, setosa, and virginica. So this is your Y or class, and these are your X here. So you've got a pair of X and Y like this. Okay, I hope this is clear. And if I go back here, and if I actually like if I load this, like all you just need to do, I can actually show you. Like if I just copy this, let me actually copy this. I know, but this is the bare minimum of machine learning I can show you right now. So we got this. Let me just run this. So this is again your collab environment, a collab notebook. Okay, so let me decipher this entire code base for you, what exactly is going on in this case. So if I like actually, like, no, let me actually first run this. You can actually name this again, iris classifier IRC. Okay, let's actually run this here. Okay, and now if I go with this one, let's actually like return X and Y. So let me actually run this here. Okay. So now if I print X here, let's say what we have here for the print like X. So these are your four values in an array. These this like you can see these values are in an array, like they are trying to mimic the the way of a matrix. So this is your matrix here. So this is your feature one, feature two, feature three, and feature four, right? And for Y, if I print Y here, I can actually print X and Y both. And right, let's actually print X and Y both. Not like this though. I can actually have it as in a similar line. I can have a end with these. Oh, I guess separator is the main keyboard. I usually just no, it is not happening. Okay, so let us say for this one, like this is quite easy. Like this is your last sample here or the last row, right? And for this one, we have this label here. Like we've got three labels, 0, 1, and 2. And for that one, like we've got here these values. So this could be your feature. This is your feature one, feature two, feature three, and feature four. Based on that, you've got your label associated with that. And now what we need to do, we need to basically train this data set here, like train our model. So you saw that curvy thing, right? The curvy thing of the 0 and 1 classifier, the binary classifier. This is we're just gonna help us to do that. Okay. So I am like you can also do this instead of making like this. I can just do this as well. Okay, clf.fit x and y. Okay, so what am I doing here? Like this is a logistic regression class, basically a classifier. Do not go with the name here. You can only consider this as a classifier right now. We don't really have to understand anything about it at this point. And where exactly I'm importing this from? Okay, so let's see. So this is from this sklearn library, and this is a linear model. Okay, so this is called an import, right? So package importing and importing, if you are not aware of it, just let me know in the chat. I mean, like no, in the chat, I'm gonna explain it. But what we are doing back with the packaging of these, like they are already pre-built classes, which we are reusing here in order to make a classifier. Okay, and when I do that, okay, so I have to instantiate an object, or I basically need to define a classifier here. And now this part is called training. मैं इसको आपको कल समझाऊंगा exactly क्या हो रहा है. Training the model. What exactly is going on? Like this part is, or this dot fit step is called training the model. Like we are training our curve, like to determine, like if a class of 0, 1, or 2, if the class is 0, 1, or 2, right? In this case, this is what is happening. And when I run this, and in this predict, like in this predict, what we are doing here, okay, let me actually cut this out as well because right now this doesn't make sense. Okay, so we have trained our model here, and on this one, like we are taking two. Okay, if I create a new like no cell here, and if I do x of 2 and everything, so what exactly does it mean? So let's see. So let's say we've got 10 lines of a matrix. Okay, and we've got four features here: f1, f2, f3, and f4, and we've got here 10 lines, 1 to 10, like this. So when I do x like this and this, like this represents row and this represents column. Okay, so when I do this to 2, it basically means 0 to 2, and this 2 won't be included. So basically what we are including here is 0 and 1. That's it. So what am I saying here? Include 0 and first row here, these two rows. Okay, just preserve, or just actually like take consideration, like take these two rows in consideration. And now you need to take care of the columns as well. So when I do this, it means all columns. So I'm taking all of these columns here, right? So I've got here two rows. Okay, so what am I doing here? I'm making a prediction on those two rows. Okay, as we saw, like on these two rows. And I'll be having like no two predictions, obviously. So let's run this. So you can see like, okay, like it didn't predict anything. I have to actually print the value, obviously. And also I have to print the value, obviously. And this needs to be printed as well. Let's run this. So you can see it actually predicted 0, 0. So it was 0 class. Okay. Probability, what exactly is going on here? Let's see. So this is your 0th class, first class, and second class. And this is again like and this is again your matrix of 2 cross 3. So we've got here 3 classes, and For each classes, it is basically estimating a probability. Okay, so highest probability I can see here is this, like 9.8 multiplied by 10 raised to power minus 1. So basically it's 0.98 here, like 98% probability. This is 1.8, like 1.8 multiplied by 10 raised to power minus 2, so it is 0.018, right? This is again quite low. And similarly, it's extremely low, like it is in the range of 10 raised to the power minus 8. So highest probability I'm having here is for the zero. So that is why I'm having a zero here. Similarly, for this one, this is 97%. So therefore, I'm having a zero here. So you can see like the score here, I can see here, like my classifier is 97% of the times is correct when making an estimation, when makes an estimation. It is not true thoroughly. There are some parameters which you need to take care of, but for now, it is true. Just consider or just take my word for it. Okay, so this is your guys' machine learning systems and the way you need to see machine learning in journal. So yeah, this is it. So if you have any questions, then please let me know. Uh-uh, uh-uh. Any questions? So random state is equals to zero means. So random state is equals to zero means basically we try to generate similar distribution for the data whenever we train. That is what we do. Like it will just gonna generate the similar distribution again, right? Not the similar ones. Like let us say we have got here for 5 iterations, we have got here A, B, C, D, and it is for random state zero. So each time it will be the like no inform like no, sorry, the distribution will be A, B, C, D. And if I say one and the distribution is B, C, D, A, so for each iteration it will be B, C, D. Let's actually not get into that because it is actually related more to the training part here. So where we can get this collab notes? Good question. Okay, let me actually. I guess like it's really not a note here. You just need to go here on SQL and logistic regression. That's it. Like that is where I copied everything from. Okay. Any questions? All right. That is great. No, sir. So is this clear to every one of you? Like, I hope this is clear. I know this was not so thorough, not so detailed. Like no, but I made sure like you do actually get basic understanding of machine learning. The intuition actually matters here, not the details. Just remember this. Because when you buy a car, you don't really get into the engine and you just start to see like well, how exactly it was manufactured, right? Like you literally buy the car, you literally have a feel of like how exactly like it is moving. So similarly for me, this is the same case. Instead of diving deep into the concept, let's actually try to play with the concept first. How exactly it is making you like how exactly it is making you think about certain context or topics about like in this case it was machine learning and your data set, right? Like we literally made a concoction of linear algebra and and simple data sets, and that's where we understood everything like about the machine learning and everything. Okay, so are there any questions? So for the last week I got just a sec, I can post. Okay, so for that I guess I have just a sec. So, okay, so this is something we will gonna start at Let's Upgrade. So, if you are interested in full stack programs as such, this in machine learning and deep learning and data science, we are starting off a new batch on 27th of August. Okay, and we do not believe in recorded sessions at all. Okay, even myself, I have taken maybe like 4 to 5 batches so far, even at LU. I have never recommended any of my students to go and watch a recorded video. Like they will be recorded video, but those recorded videos will be part of your live streams. Okay, like we believe in 100% live teaching. There will be obviously 200 plus hours of learning for sure. And live doubt clearing, I always ask, like I do not really proceed if someone has a doubt. Like I make sure always, and like me, there are amazing trainer at LU who also makes this show. And 6 months, I guess like it's enough to learn a skill. One-on-one mentoring will be provided, and there will be 15 capstone projects as well. Okay, and after that, like we can actually see this is the I mean like what exactly like this is the winners list. So the winner is Ritik Sanjay Patil. So congratulations for that. And second is Mangli Lakshmi Kant. Congratulations. And Mohammed Fardeep for 100 alicorns. So congratulations, guys. Okay, and congratulations to Ritik as well, like for getting 500 rupees Amazon coupon here. Okay, all right. Thank you. Any questions? If you have any questions, then please let me know. Okay, I guess we are done then because since I don't see any questions here. Okay, so thank you so much for joining in, and I'll see you around. I guess like we are done. Okay, bye bye.